the main inputs into this plant is we have grass silage here in the 2 clamps behind us, and we have agricultural beef slurry from a beef unit down the road here. The grass silage is fed into a solid feeder here beside us, which is then fed in on every hour. There's so much kilos fed in. We're feeding, I think, approximately 30 tons of silage in here per day for an electrical output of about 500 kilowatts. Our cattle slurry is I'll walk over here, Gary.
Let's just have a look at this product here. So what have we got here, Pat?
Third cut silage, so it's obviously a bit on the wet side. Basically, we cut three cuts of silage here per year. The first cut normally is cut around the middle of May, the second cut around the middle towards the end of July, and the third cut then around the end of September. The energy values obviously will vary. The first cut energy value of the product would be a lot higher. We'll be talking in terms of dry matter, DMD value will be up on 82% on the first cut, and now maybe around the 74-75% by the time you get to the third cut.
Okay, so that's one of our feedstocks.
Yeah.
Okay, what's our other feedstock?
The other feedstock is agricultural slurry, so beef slurry coming out of a beef unit, same as you'd have in most slatted sheds throughout the country. We normally try and, I suppose the beef slurry is a higher dry matter than what you get in dairies because of all the washing and stuff, so we try and focus on that, and the energy value of that is a good bit higher.
Okay, so we're here now, we've got one of our inputs, and our inputs are taken over towards the plant. Just talk us through the plant here that we're looking at now. So we're looking at 2 storage units there.
Yeah, so we have 2 digesters here. We have a primary digester, which is the one with the gas bubble on the top that's up at the minute, and we have a secondary digester, which is the one on the left-hand side. The material, the liquid material, which is the slurry and the silage, enters the primary digester, where it's heated to about 46 to 48 degrees. There's 3 agitators located in that, which constantly keeps the substrate mixed, and by keeping it mixed, you release the biogas, the biomethane from the liquid.
Okay, so this machine here, tell us about that. What does that do?
So this is the feeder. This is the solids feeder. So we feed the solid material in here. You can see the silage at the top. So that's fed in with a loader.
Yeah, and we've currently got what have we got there? 15 tons. Okay.
In that 15,420 kilos. So that material then is fed every hour. You can see it's feeding at the minute. So this is a pre-mix system, so we basically use substrate out of the tank, is recirculated in here, mixed with the silage coming in here on this auger, and fed back into the tank as a sort of semi-liquid sludge into the tank.
Okay, so the big tank here with the, I suppose, the cone top on it, that's your primary
tank.
That's
your primary digester. So in this plant here, probably about 80-85% of our energy is coming out in the primary digester because the reaction time is so high. As I said, we have 3 agitators in this tank, and them agitators are constantly keeping the material mixed and releasing the biogas.
Okay, so what's this second tank here?
The second tank in is what we call the post digester. So the liquid fraction is transferred over after a relatively time of between 70 and 80 days in this tank. It's transferred into this tank here. The idea is if you were a higher throughput, I suppose, or you had less energy efficient products, that you would get the remainder of the energy out in the post digester. Obviously, you want the material leaving the plant. You want 100% of your energy to be taken from that material in order to be totally efficient.
Okay, so we've looked at our inputs. Okay, we're gonna maybe just go on to another little clip now.